Good day everyone, welcome to my YouTube channel. For today's video, we are going to solve a transportation problem in linear programming using the northwest corner method, least cost method, and the Vogel's approximation method. Before we start, kindly hit the subscribe button and click the notification bell for more updates and for more upcoming videos. Transportation problem is a type of linear programming problem designed to minimize the cost of distributing a product from M sources to N destination. For example, Geraldo Bananas has three factories, the F1, F2, and F3, with production capacity of 25, 20, and 15 units per week respectively. Their units are to be shipped to 5 warehouses, which is the W1, W2, W3, W4, and W5 with requirements of 8, 10, 12, 14, and 16 units per week respectively. The transportation costs per unit between factories and warehouses are given below. So we can see in the table the cost per unit between the factories and the warehouses. So from factory 1 to warehouse 1, 15. From factory 1 to warehouse 2, they have the cost of 17. To warehouse 3, 18. Warehouse 4, 16. Warehouse 5 is 21 and the supply is 25. For the factory 2 to W1, 18. Warehouse 2, 19. Warehouse 3, 16. Warehouse 4, 20. Warehouse 5 is 22 and the supply is 20. For the factory 3 to warehouse 1 is 16. To warehouse 2, 18. To warehouse 3, 15. To warehouse 4 is 15 also. And to warehouse 5 is 17 with a supply of 15. We can also see the demand. To warehouse 1, they need 8 units. To warehouse 2, 10 units. W3, 12 units. W4, 14 units. And to W5 is 16 units. To solve this, let us find an initial basic feasible solution of the given transportation problem using the northwest corner rule. The name northwest corner is given to this method because the basic variables are selected from the extreme left corner. The prerequisite condition for solving the transportation problem is that demand should be equal to the supply, which is balanced, and in this, the supply total of 60 and the demand is also 60. Starting from the northwest corner, we allocate 8 units to F1W1. The demand for the first column is completely satisfied, so we will cancel out the 8 and it becomes 0. Now we will reduce the supply, which is 25 by 8, and we're left with 17. In the case that the demand is more than the supply, then the dummy origin is added to the table. Since this is balanced, the following procedure is followed. First, select the northwest or extreme left corner of the matrix, assigned as many units as possible to cell F1 and W1 within the supply and demand constraints, such as 8 units are assigned to the first cell that satisfies the demands of destination W1 while the supply is in surplus. Now, move horizontally and assign 10 units to the cell F1W2. The demand of destination W2 is fulfilled and the supply is still in surplus. So continue to move horizontally and assign 7 units to the cell F1W3. Since we left with 7 units to satisfy the supply, while its demand has only 5 units. Ngayon naman, move vertically in the matrix and assign 5 units to cell F2, W3. The supply F2 left with 15, while the demand for W3 gets fully saturated. Again, move horizontally and assign 14 units to cell F2, W4. The demand of destination W4 is fulfilled while the supply is in surplus, which left with 1. Next, continue to move horizontally in the matrix and assign 1 unit to cell F2, W5, since 1 unit is available with source F2. The supply gets fully saturated while the demand has 15 units. Lastly, move vertically and assign 15 units to cell F3, W5. Now, both the demand and supply of origin and destination get saturated, so the total cost can be computed. We now have here 1, 2, 3, 4, 5, 6, and 7 occupied cells in our matrix, and Rm plus n minus 1 is equal to 7. The source stands for M, which is 3, the F1, F2, and F3, while the destination stands for N, which is the W1, W2, W3, W4, and W5, then minus 1. Now, to compute the total cost, we have 8 times 15 plus 10 times 17 plus 18 times 7 plus 5 times 16 plus 20 times 14 plus 22 times 1 plus 17 times 15. This equal to 1053. And we're done with our northwest corner method. The total cost for our transportation problem using the northwest corner method is 1053. Now, let's proceed to the least cost method. This is another method used to obtain the initial feasible solutions for the transportation problem. Here, the allocation begins with the cell which has the minimum cost. The lower cost cells are chosen over the higher cost cells with the objective to have the least cost of transportation. The LCM is considered to produce more optimal results than the northwest corner because it considers the shipping cost while making the allocation, whereas the NWCM only considers the availability and supply requirements, and the allocation begin with the extreme left corner irrespective of the shipping cost. In the table, the minimum cost in the matrix is 15. Since we have a tie in the cell F1W1, F3W3, and F3W4, now the question arises in which cell we shall allocate. It depends on you where you want to assign, and for me, I prefer to start in F3W3. So we have the demand here of 12 and the supply of 15. Hindi natin pwedeng i-allocate dito sa 15 kasi lalagpas siya sa demand natin. We will always choose the least number between the supply and the demand. Since here, 12 is lesser than 15, we will assign it to cell F3W3. With this, the demand for the destination W3 gets fulfilled and only 3 units are left with the source F3. Again, the minimum cost in the matrix is another 15. I choose to assign in the cell F1W1. Therefore, 8 units shall be assigned to the cell F1W1. With this, the demand of destination W1 gets fulfilled and only 17 units are left with the source F1. The next minimum cost is still 15, which is in the cell F3 and W4. Since here, the supply is lesser than the demand, which has 3 units over 14 units, so we will assign 3 to the cell F3 W4. The supply of source F3 gets saturated and the demand of destination left with 11. Now, another minimum cost is 16. We also have 316. But however, the demand for W1 and W3 is completed. So we will move to the remaining 16 in the cell F1 W4. We will assign 11 to the cell and the demand of destination W4 gets fulfilled and only 6 units are left with the source F1. Next will be 17. We have two 17 there in F1 W2 and F3 W5. In F3 W5, the supply is fully saturated, so we will move to the cell F1 W2. The supply of source F1 has 6 units and the demand for destination W2 is 10. The less will be in supply, so we will assign this to the cell F1 W2. And here the supply is fully saturated. Only 4 units are left with the demand. Now we will move to 18. Since the demand of F2W1 and F1W3 is fulfilled and the supply for F3W2 is fully saturated, we will proceed to the next list number. We now have 19. We will assign the 4 in the cell F2W2 so the demand of destination W2 is fulfilled and the supply for the source F2 left with 16. Next 20 is already completed in the demand of destination W4. Now 21 is also fully saturated in its supplies. So we will lastly have 22. The remaining supply for the cell F2W5 is 16 and the demand is also 16. So if we assign 16 to the cell, the both demand and supply of all the sources and the regions gets saturated. The total cost can be calculated by multiplying the assigned quantity with the concerned cost of the cell. Therefore, 15 times 8 plus 17 times 6 plus 16 times 11 plus 19 times 4 plus 22 times 16 plus 15 times 12 plus 15 times 3 is equal to 1051, which is lesser cost than the northwest corner method. The third method would be the VAM or the Vogel's approximation method or the penalty method. This method is preferred over the NWCM and LCM because the initial basic feasible solution obtained by this method is either optimal solution or very nearer to the optimal solution. To solve this, find the cells having the smallest and next to smallest cost in column and write the difference called column penalty over the table. Here in our first column in W1, we have the smallest is 15 and next is 16. So 16 minus 15 is 1. Next column is the smallest is 17 and 18. So 18 minus 17 is 1. Next, here 15 and 16. So 16 minus 15 is 1. Next is 16 and 15. So 16 minus 15 is also 1. Lastly, 21 and 17. So 21 minus 17 is equal to 4. Next, find the cells having the smallest and next to smallest cost in each row, and write the difference called row penalty along the side of the table. In the source F1, the smallest cell is 15, followed by 16, so 16 minus 15 is equal to 1. In F2, 16 followed by 18, so 18 minus 16 is equal to 2. Next, in F3, the smallest cell is 15 and also 15, so 15 minus 15 is equal to 0. Next, select the row or column with the maximum penalty, and then find cell that has least cost in selected row or column. Here, 4 has a maximum column penalty. Then the cell that has least cost in this column is 17. So we will allocate 15 from the supply to this cell, so it would be fully saturated and the demand remains 1. We will strike out this satisfied row. We will just repeat these steps. So we have 1, 1, 1, and 1. Here we will not include the 17 since it is already a satisfied row. We have the smallest cell of 21 followed by 22. So 21 minus 22 is equal to 1. Then in the row we have 1, 2, and this last is completed. So we will not just put a simple dash. Here, the maximum penalty is 2 in row penalty, and the least cell is 16. So we will assign the 12, and the demand will be fulfilled, and the source of supply remains 8. So we will strike out this column. Next, 1, 1, dash, 1, 1, in row, 1, 1, and dash. The maximum penalty is 1. So it depends on you on what you choose. For me, I choose the first column. The least cell here is 15. So we will allocate 8 since it is lesser than the supply. This column will be strike out and the supply left with 17. So dash 2 dash 4 1. In row we have 1 1 and dash. The maximum penalty here is 4. So the least cell here is 16. So we will allocate the 14 in its demand. So this is fulfilled. And in the supply, we will reduce the 17 by 14. So we're left with 3. So we will strike out this column. Next, here is dash 2 dash dash here 1. In row we have 4 here since we will not include this column in W4. We have the last cell of 17 and 21. So 21 minus 17 is 4. Then here 3 and then dash. The maximum penalty here is 4 in a row penalty. So we have the last cell in this row is 17. So we will allocate the 3 there. And the supply is fully saturated while the demand remains with 7. Next, dash. Here, we only left with 19. Then, dash, dash. W5 column also left with 22. In row, we have dash, 3, and dash. The maximum penalty is 22, so we will choose the W5. The least cell here is 22. Since we left with 1 in our demand, so we will allocate it here. Then this demand is fulfilled and the supplies remain with 7. Now dash 19 dash dash dash, then dash. Here we only left with 19, then dash. The maximum penalty is only 19, so I prefer to choose in the column penalty. So we have the least cell of 19. So we will allocate here the 7, the remaining 7 in the demand. So this is fully saturated, and in the supply is also saturated. So we're done. The total cost now can be computed. So we will use also the occupied cells. So we have the 15 times 8 plus 17 times 3 plus 16 times 14 plus 19 times 7 plus 16 times 12 plus 22 times 1 plus 17 times 15 in the total of 997. So obviously this is the method that has a least total cost among the 3 methods. So we will use it in our Moody. To proceed in our Moody, we will use the table who have the least total cost, so which is in our Vogels. Next, the factory, we will let it as our U1, U2, and U3, and also in our warehouses, we let as V1, V2, V3, B4, and B5. Also, we let our U1 as the value of 0. Now, for the roots used, we will add the U1 and the V1. So, U1 plus V1 is equal to 15. Since our U1 is 0, 0 plus 15 is equal to 15. Now, since we already have the value for our U1, we will find the value for our V1. So, using the algebra, we will transpose it. So, we have V1 is equal to 15 minus the U1. Since the value for our U1 is 0, so 15 minus 0 is equal to 15. Next, in our U1 plus V2. U1 is 0, then our V2 is 17. So 0 plus 17 is equal to 17. Now we will look for the value for our V2. So we have 17 minus 0 is equal to 17. Next, U1 plus V4. So 0 plus 16, we have 16. And we will look for the value for our V4. So V4 is equal to 16 minus 0 is equal to 16. Next, in our U2, since we have the occupied cells here in V2, V3, and in B5, we will first compute in our V2. So U2 plus V2 is equal to 19. And then next, using the algebra, we will transpose it to find the value for our U2 since we already have the value for our V5. So U2 is equal to 19 minus V2. So U2 is equal to 19 minus the value for our V2, which is 17. So 19 minus 17 is equal to 2. Next, in our U2 plus V3. U2 plus V3 is equal to 16. So since we already have the value for our U2, we will look the value for our V3. So V3 is equal to 16 minus 2 is equal to 14. Next, U2 plus V5. So U2 plus V5 is equal to 22. And the value for our V5 is equal to 22 minus 2 is equal to 20. And then, lastly, the occupied cells in our U3, which is in V5. So U3 plus V5 is equal to 17. Since we already have the value for our V5, which is 20, and we don't have the value for our U3, so we will look the value for our U3. So U3 is equal to 17 minus 20 is equal to -3. Now for the unused roots, so we have the U1 and the V3. So U1 plus V3, this is from the table, minus U1 plus V3 for the roots used. So U1 plus V3 in the table is 18, minus the quantity for U1 from the roots used is equal to 0, plus V3 for the roots used also is 14, so we have 4. Next is U1 and the V5. So U1 plus V5 in the table is equal to 21, minus the quantity of U1 from the roots used is 0, plus V5 in our roots used is 20. So this equal to 1. Next is U2 and the V1. So U2 plus V1 in the table is equal to 18, minus U2 from the roots used is 2, plus V1 from the roots used also is 15, so we have 1. Next is U2 and V4, so we have 20, minus 2 plus 16 is equal to 2. Next is U3 plus V1 is equal to 16 minus -3 plus 15 is equal to 4. Next is U3 and V2 is equal to U3 plus V2 in a table is equal to 18, minus the quantity of U3 in a roots use is equal to -3, plus V2 in a roots use is 17, so we have 4. Then U3 and V3, so we have 15 minus -3 plus 14 is equal to 4. Lastly, the U3 and V4. So we have 15 minus -3 plus 16 is equal to 2. So we can see in our unused roots that there is no negative sign. Since there are no negative sign, therefore, there is not possible to reduce the total cost. So we are now done. So next of this is the looping. And in looping, we will just loop those value who have negative sign. So since here in our unused roots there is no negative sign, so we don't need to proceed in our looping. That's the end of our video for today. Thank you for watching, guys. Bye.